Welcome to Kellogg's Global Politics, a podcast on current events in U.S. foreign policy and international affairs. My name is Anita Kellogg. I'm here with Alex Montgomery and Shannon Waller to discuss the autonomous systems and robotics industry. Alex is a lieutenant colonel in the U.S. Army, and Shannon is a lieutenant colonel in the U.S. Marine Corps. Both Alex and Shannon recently wrapped up their study of the autonomous systems and robotics industry at the Eisenhower School of the National Defense University. During the program, they met with industry leaders and other key figures to gain a comprehensive understanding of the challenges and opportunities this industry faces. So, hi, Alex and Shannon. Thank you so much for coming on the show.
Hi, thanks for having
me. Good morning. Thank you for the opportunity to join you on your podcast today.
Oh, I'm so happy to have you guys here. So just to kind of get into it, how would you describe the autonomous systems and robotics industry? What all does it encompass?
Yes, I'll start. I think the autonomous systems and robotics, or AS&R industry, encompasses multiple industries, but they're really focused on combining machines or hardware platforms of some sort with software, often using artificial intelligence or AI, so that machine can operate independently or semi-independently. And then these systems or vehicles kind of mirror and extend human capabilities as we've learned across the three domains. And so that's land, sea, or air. And each of these machines kind of have what I would say is four different components. So they have some form of ability to sense and analyze the environment around them. So a sensing component. They have a perception and kind of decision-making component, so they can interpret the data or the analysis that they're getting from the environment and then kind of make a decision using that new cool AI or software. Then there's a control mechanism that kind of executes the actions based on that interpreted data. And then obviously some mobility or movements, manipulation, where that platform physically interacts with the environment around it so that it can move and get away from obstacles. And so when we're, thinking from a wartime environment, probably the most popular system or platform that we're talking about in the AS&R space is a drone.
Right. So that's a good introduction to it. Can each of you name a couple of key takeaways from your study of the industry?
Yeah, I think one of the biggest things when it comes to autonomous system robotics is that there's a wide range. I think we're going to get in maybe this a little later as well, but automation's been around for a long time. We think now it's all robots and AI, and that is kind of the extreme or the edge we're trying to get to, fully autonomous things. But it's a wide spectrum of automation, and where the human, I think, is one of the big takeaways, where the human is going to intervene with how the machine operates, whether it be warfare or driving a Waymo car or something like that. So it's if you try to kind of box this in, you're kind of missing the big picture of what automation means, and it means different things to different industries. And as it goes along, it probably will continue, and some things will probably never be fully autonomous, just based on some of the constraints we could talk about as well. Also, I'd say it's a very challenging and expensive kind of area to get into. So when we talk about getting to certain places with private capital or if it's government funding, it just takes a lot of investment to get it there. And so when you have a lot of people getting in there, if there's no coordination or synchronization, really developing and getting to where we want to go will require some cooperation in various levels of government, academia, industry, even foreign partners, et cetera, if we really want to accelerate automation itself.
Great. Alex?
Yeah, I think the biggest takeaway is a lot of the technological advances that we're seeing in these AI software systems combined with, geopolitical factors. It's really changing the character of warfare, and it's responsible for driving significant growth in AS&R. And so there is a a drive across defense industries, not just in the U.S., but globally, to get into that space, to get into ASNR so that they can use that in warfare or in preventing and deterring that in the future. But I think one of the biggest things that we learned kind of throughout is due mostly to the vulnerabilities in the supply chain and kind of some of the lack of the human capital or workforce. There really is kind of an inability here in the U.S. to scale production specifically, but to scale production for a lot of these ASNR systems, not talking about 10, 20, but hundreds of thousands of systems
Right.
that we would need. We're just not there. Now, maybe some of the primes have that capability, but are very unique, cool, new, high-tech firms don't necessarily have that capability to produce at the level that we would expect for the Department of Defense. And I also think for some of these high-tech firms, there is kind of an overinflated sense of autonomy, claims of, what drones can do in the EW space and what ground autonomy can do moving around obstacles. That combined with the lack of expertise broadly across the DoD of what, Shannon was talking about, what autonomy really means, the full scope of it. I think that creates risk for us. And there's a lot of leaders out there that really aren't pushing forward ASNR maybe as much as they could because of that lack of knowledge and some of that overinflation in autonomy claims.
Yeah, and your point about supply chains is a really interesting one and really relevant. So you mentioned drones earlier, and certainly when I mention this subject to family and friends, that's the first thing that comes up and how it has impacted the Ukraine war. And then many may also be familiar with the stunning Operation Spiderweb recently, the large-scale Ukrainian drone strike against air bases across Russia, primarily targeting Moscow's fleet of strategic bombers. Is the way wars are being fought changing? And if so, what products are coming out of this industry or are in development that are most likely to impact this change?
Yeah, I'll take that. I think absolutely the war is changing, and I think with the in reality, the overall long range of new weapon systems, lethality, and just the overall weapons industry, what they've come out with, we've have to decide that we want human standoff, because attrition wars you see in Ukraine is not real pretty. And Ukrainians who are defenders, they have that advantage, but they're much smaller size. So they've really been able to capitalize on their ability to harness their organic industrial base, if you will, to make UGVs or unmanned ground vehicles or uncrewed ground vehicles, and then unmanned aerial vehicles to inflict a lot of damage or at least slow down the Russians. And the Russians have then countered with a lot of their own stuff, bringing in Iranian Shaheeds and things of that nature. What you see is a lot of robot on robot or robots trying to find humans, and it's creating a lot of human standoff, which is a positive for humans, but it also creates this idea of you're going to have, as Alex said, you want tens or hundreds of thousands of drones, just a large scale of weaponry that is continuing to evolve. I saw a picture the other day of all the fiber optic cables laying over a wheat field in Ukraine because of all the Russian jamming. So now the Ukrainians have gone to fiber optic cables, and so has the Russians. So it's very interesting. It's normal course of warfare. Someone creates a weapon, they use it. Someone finds a counter to it. They go back and forth, and ultimately you have a cocktail of these weapons out there, and just more and more advanced. And eventually, I guess some of them might have all these counter capabilities and be very, very lethal. But I think until like the AI part of it's really solved, and I think the operation you spoke of, reportedly they smuggled the drones in and then launched them out of trucks, and a lot of them were jammed, but they just continued full autonomous. So we have, obviously there's some ethical considerations on everybody's side, but specifically for the U.S. and how you're going to fight that war, or are you ever going to unleash that, or are you going to constrain yourself against your adversary to a point? So I think it's really accelerating kind of the way you take a simple large number of drones and use them, and then to what degree are you going to use them based on where you're at in warfare? Are you losing? Are you winning? Are you in an urban area? Or are you in an open battlefield? So it raises a lot of questions that aren't necessarily new, but just in a different way to view them.
Yeah, that makes a lot of sense. Another topic that comes up is whether it will have a substantial impact on human labor. So, in some countries with labor shortages, like South Korea, this is one of the appeals of developing the robotics industry. In the US, however, there's more concern over dramatically reducing employment in a number of fields. How likely is this to happen in the next 10 years or so? And are people right to be worried?
Yeah, I'll take this one because I think it's a great question to look at the short-term and long-term impacts of automation and production. And, actually to take the question a little bit further, how business is using large language models or LLMs in administrative jobs is also something to look at. Um, Ultimately, economic incentives that drive the adoption of this automation specifically and the use of LLMs, I think is going to determine the labor impacts. But I don't see a drastic reduction in human labor requirements overall. I mean, whether we're looking 2 years out or 10 years out, I think, what I see and what's in a lot of the literature out there is it's more of a shift in employment requirements than a reduction in employment opportunities. And so robots operating in the manufacturing space specifically are definitely going to increase the effectiveness and efficiency of production for those repetitive, we talked about dangerous, dirty type of tasks. But it's always going to require skilled technicians to program these robots, to maintain the machines, to make sure that they're working to the utmost of their capability, because they are expensive machines. Even though they can continue to work for 24 hours, the amount of capital to get those machines on the line is really high right now. And so I think because of that, there's always going to be an opportunity for current employees that are working the line to maybe shift to a more specialized, skilled role where they're doing some of the programming of these robots or some of the maintenance, or they're advising, so to speak, but not necessarily getting rid of all of that labor. From an administrative perspective, looking at LLMs and how, Chat GPT and Gemini and some of those others are going to work from, an administrative aspect. I see them actually augmenting employees and managers, not replacing them. So we're doing things more efficiently. That kind of human machine collaboration is happening, so we get a more effective product down the line. But I don't think the long-term impact on the workforce is going to be a reduction in jobs. I think more of the fear is there is going to be change. And so our job market is going to have to shift a little bit and focus on what these robots and LLMs can do and what they can't do, and focus the job market on what they can't do and specialize in that area.
Yeah, I just want to push back just a little bit in that more efficiency usually means you need less people. And even if you are transferring some jobs to the more technical side of helping to maintain the robots and program the robots, it does seem like overall you wouldn't need as many of them as you need currently in the manufacturing line. So how would this not be a dramatic effect on employment?
And I think a lot of that is we figure out where it works for robots and where it doesn't. And so in our travels, we were able to see in this kind of extensive field study that there's certain very detailed electronic components that it may not matter how detailed this robot gets. Human hands and expertise are going to be the right way to go to make these very detailed electronic components. And so it will be more of a shift from what the robot can do to what the human can do. And as we continue to become more efficient, more effective, we're becoming, more high tech. There's better systems out there. So those high tech systems are going to require more refined, smaller, detailed, specific tasks that maybe it's human machine kind of teaming to get it done. But more than likely for the next 10 years, I think you're looking at humans are doing that very detailed, technical oriented work.
If I can just
Yeah,
add on,
that's
I, I think what Alex brought up at the beginning, the dirty, those jobs that a lot of humans don't want to do those anymore. So that's the first area where we've substituted, I think, the, drones inspecting pipelines or going into, places that are dangerous for humans to be, that there's just not, people just don't do those anymore. So, and I think this follows the evolution of technology advancing employment and labor shifts to different industries. Take India, they have a large service telecommunications industry coming from a very agrarian society. They still grow food, but a lot of their employment is in medicine and service industries and things of that nature. So I think when we fill those in, now there's always the threat of, I think the crux of the question is, when you're dealing with the government, how do you not displace a bunch of workers just by businesses want to become more efficient, and then you have a significant unemployment problem, which is fair. But I think, again, we're starting at the areas where people don't want to fill in, and the South Korean model is exactly that. They know they have a birth rate decline, and so they're not going to have the number of workers they need. So they're immediately filling that in with robots, and then applying that technology and expanding it through other ways to continue to help out their defense industry and other things. But it is an important question and something to wrestle with.
right. I think that's great. And you make a really good point in that these dull, dangerous, dirty jobs, there's already like shortages there. And being able to have robots to be in a place that humans don't want to take those jobs anymore is a really good point. So we brought up South Korea, and the industry study spent a week there learning about their autonomous systems and robotics industry. So, what are the couple of the key insights you gleaned from studying their industry?
Yeah, I'll jump in first. And so I truly enjoyed the opportunity to visit with the defense firms specifically in South Korea, because their mentality about defense, and actually many times how the South Koreans discuss that they're still at war with North Korea. So not being over there before, that didn't even cross my mind. And you have very high level executives talking about being at war. That really shifts the mentality and the focus on defense and allows them to make some clear decisions on policies and resources regulating how they do their defense production. So one of the key insights that I took away, that I think our group really looked at, was this idea of they have a national robotic strategy. So government, top driven, down, focus on robotics to, not just the defense industry, but get more robotics into industry overall. And they're backing that strategy with funding for universities, government agencies, trying to improve the workforce, and all of that to foster innovation and economic growth that then goes into them being a more capable defense industrial base.
Yeah, I think that's a great point.
Yeah, Alex hit on it. I've been over there about a half dozen times, different times in my career, and one thing is they're a home team, and they're always prepared for the conflict. So they have to think about things differently. We're guarded by two oceans, so when they've incentivized their companies to make something, they literally do a good job of partitioning. Like, one company's going to make a howitzer, maybe another one's going to make a tank, and that's foreign to us, no pun intended, but we throw it out there and let a lot of people compete. And they kind of, like, for the sake of efficiency and the necessity, they've kind of said different companies are going to be doing different things. We're going to give you the money up front to help you, share in the burden, but we've got to get these things online. And then the fascinating thing on the backside is, once they've developed it for Korea, then they say, hey, you're allowed to make more money. Now you go export it. And the South Koreans have become a chief exporter in military hardware around the world, specifically now more in the Middle East, which is a very fascinating model and something we may get into as well with our exports. But they just have a different mindset, I think, when it comes to it. Now, how they think of the machines may be the same, but the way they, on the front side, get to where they can develop and actually start producing and scaling their autonomous systems or anything in their defense industry is just it takes on that different characterization based on where they live, and their threat is connected directly to them by land to the north.
Yeah, I think that perspective has always struck me too when I've been in Korea, the sense of being at war or just having a different security, ever present security challenge and how that affects things. And your point about it being very top down, I wonder how much innovation then you get from the bottom up. Like most of the companies we saw were pretty big companies.
Yeah, Dr. Kellogg, you mentioned their ability to innovate and how it is, and this ties right in. I think how they're different is they're very much looking outward to the U.S. and other, friendly nations to partner with them because they know. I mean, they're very engineered, very innovative, but because they're partitioned, you're right, to maybe overcome that. We had talked to numerous other companies. They were like, we want more, we want a better relationship, or we want easier way to get the U.S. over to help us develop things. And we've done that with the F-A-50 fighter. I think the F-35K obviously is a overall joint program. And now we're working in things with LIG Next One and some unmanned or uncrewed surface vessels paired with weapon systems of theirs. So they're looking for a way to harness our innovativeness as an ally to help, I think, overcome that. And I think that's a smart thing on their part. Whereas the U.S., I think we're a little less willing to. We're worried about IP and the security classification of the things that we organically come up with. So it's one of those obstacles and I think that's a bigger issue for maybe another podcast is how do you, as the U.S., take that leap of faith and release more of your IP, et cetera, to try to get your foreign partners and trust them to make the overall system better. For right now, we largely try to do a lot of things on our own. And I think the Koreans are very smart and they know what they can do on their own. Large manned end items like tanks and howitzers that they have a tradition of, partition those off. And then all the new drones and things, I think multiple other companies are making those. They go, hey, we need a little more help. And because this is the next thing, but we don't necessarily have the capacity or necessarily the know-how and innovation right now, but we need it. And we want our partners to help us out.
Yeah, I mean, that's a really good point about collaboration between the countries and also what the U.S. Would get out of that and sort of filling some of our gaps as well. So kind of moving back to what you were talking about, Shannon, about there's no like automation versus non-automation, that you guys developed a 5-point scale of automation where 0 represents no and 5 is full automation. So what level of automation are most companies in the defense industrial base?
Well, I think I don't know if we adopted or made our own. We kind of used the SAE automation levels to kind of recommend that overall industry multi-domain, that the DoD come up with some kind of standardization. So if I'm using the SAE one, so I think we're somewhere living between generally 2 and 4, which would be partial automation, conditional automation, and high automation. So probably conditional automation, and basically it right now we're kind of where a operator is a necessity, but it's not required all the time. So we can put in mission profiles for UAVs or any uncrewed vehicle, have it go out and do a certain mission set. But at some point, the human's got to be ready to take control, passing on additional instructions, et cetera. And that a lot of that's because of to the right of that high automation, full automation, the more you bring in that edge compute, artificial intelligence, it's just not going back to what Alex was saying. Some of them are overstated, and it takes a lot of investment. For example, reinforcement learning to get things where we could trust that machine can operate on its own. So I would say a level 3, which is a pretty good space to be. But when you consider that our adversaries who maybe aren't fettered by ethical or moral limits are going to go full automation, and just what happens. So there is definitely some pressure to move, and it's the balance of how do you fund the right people, doing the right thing to get it there. And with the U.S., we're very obviously open capitalistic market. We try and we fail a lot, but probably not as fast as we need to be. And we don't have and this goes to one of the challenges, the R&D and the scalability I know Alex spoke to earlier, to identify what are the real innovators who are doing it the right way, and we can trust their thing, and what's their ability to make their product even better through that reinforcement learning, then we could get the trust up to where high automation or even full automation is a real something that we ethically, morally can put into the use specifically on the battlefield.
Yeah, so going off what you're saying, it seems like trust is maybe one of the chief obstacles to achieving full automation. Are there any other large obstacles that you see?
Yeah, I think just to jump in, that really depends on the domain. So if we're talking land, sea, or aerial automation, as we saw in a congested, land environment, the perception of really full automation or even into that 3 or 4 is maybe just not there yet. And so the main obstacle for a lot of it is software related. That the AI, the sensing, perception, back and forth is just not connected in a way that decision making is as fast and focused as we need to be for some of those robotic, wheeled, or tracked vehicles. But from an aerial and underwater domain kind of perspective, they they operate in less complex environments. Um, and so I think you can get to higher automation quicker with less complex AI stacked on top of each other. But really, the definition of a level 5 or full autonomy is the ability to operate in any environment. And so I think one of the chief obstacles there of a level 5 kind of fully autonomous vehicle is communication with that vehicle. And then as Shannon kind of pointed to, what is the user's comfort level with that platform's capability?
Yeah, and Shannon, you mentioned, the ethical considerations. So, what are the implications of full automation with respect to both ethical and security concerns?
Oh, that's a tough one. The ethical one's the biggest thing. I think both the Russians, Ukrainians are doing they're doing full autonomy in the sense that they have pretty big standoff in most areas unless they're attacking urban areas. So I think they have a fairly high confidence, if they care, that they're attacking valid military targets. But I think for us, in a lot of places we've fought wars in, that are congested, that with heavy civilians and things like that, and misidentification. And so perfecting targeting is, and I know that there's this going on in the news with Gaza and the Israelis too, how they're using lavender to target, and what is the acceptable confidence level before they're going to strike a target. And again, a little bit more existential, on their end, where maybe they can justify it, whether that meets the world's or our U.S. Level of comfort. I'm not sure that necessarily does or does not. I don't have the full reading on what they're exactly doing, but having seen strikes in those areas, you have to be very good. And there's a lot of things that blend in. And as we learned in our studies with a couple things, there's ways to spoof artificial intelligence and targeting, and it's a real grave thing, especially warfighters, because I think people that are pulling the trigger or hitting the button or whatever you want to say to execute a strike, they want to know for their own selves. I think almost to a person that their confidence in what they're doing is going to elicit the effect, or at least not harm civilians in the process of doing that to the utmost. So there's full automation. It's here. We can do it, but again, it's the confidence level of what you're going to do that, and that goes back to that reinforcement learning. We visited a firm that does specifically imaging for targeting, and they talk through how they run back through the images, and they allow their automation to pull. They use it in the part that Alex is talking about administratively, like, hey, we're going to narrow these things down from our surveillance scans, and anything we don't fully understand, we're going to flag it for human intervention. So that's not full, but it allows them to continue to refine that process and add to that data. Now, where that gets to perfect, when again, there's always a counter for something. So the issue is, if someone figures out what we're doing or can figure out how to spoof it, then now we're going back into reinforcement learning again, and how do we over and over again. So it's going to be ongoing. So full automation is maybe a pinnacle we touch, and then may get knocked down from it based on counters. And we're going to continue to wrestle with, I think, what we're comfortable with based on the situation. So it's not an easy question. It's definitely what a lot of folks are aiming towards, because if you can get that, that's the golden goose. If you can get there and prove that you can do it with trust, I think you're going to be a DoD customer for probably a long time in that regard.
From an ethical perspective, we may not want to get to full level 5 automation, instead push towards the tactic of man in the loop framework for all lethal, autonomous systems. There can be full automation for other systems, ISR, recon, that kind of stuff, because I just don't think we're at the point, in society and with the Department of Defense where taking a human life should be an algorithm of ones and zeros. And I'm not sure that, because there still is kind of a lack of understanding of autonomy and what goes on inside, that we won't just push to a more man in the loop tactic. But, as we talked about, there's increased risk to that, because anytime we want to communicate with an unmanned vehicle, we're delaying targeting actions, adding communication vulnerabilities, kind of into the mix. But, that was kind of what I was getting at with my last comment, that it's about comfort. How comfortable are we with the systems and what they can do? So I think if you're looking short term, it's definitely going to be a man in a loop type of scenario, because I don't believe that comfort is there yet. But as Shannon talked about, once we get a little bit more comfortable with the AI stacked on, a lethal unmanned vehicle, maybe we do push in certain scenarios, specific targeting packages for a full level 5 autonomy where we are hands off.
I think Alex is right on there. And here's just to exponentially make it more complicated. When we're talking about one drone that's programmed to go strike one target, that's a complex problem in itself if you're going full autonomous. Now, the vision is, and it's the way we've operated in crewed vehicles of all domains, we're all data linked together. So I might have a drone go find a target that's backed up, Reaper per se, that's got an operator, a whole PED cell behind it. That's, yes, this is the target, and it's a good target. And then I have to find that target by some means in my F-18 and then confirm it, and then I'm going to strike it. Well, if we're talking about now pull humans out of all that, I have a autonomous targeting UAS that's going to find a target, and then it's going to hand off to we'll call it the killer, so a hunter-killer team, to another asset. And these assets may be made by different companies with different levels, I would say, trust. But now you're wrestling with the fact that now it's the information they're communicating. Is their own AI good enough to do full automation? And is the command and control system high fidelity? Then we trust that. So that it makes it infinitely more complex when you tie into that. And I think one of the main recommendations we came out of our study was the open systems architecture, where, okay, everybody can maintain their own IP, which is another topic of discussion in this field that limits innovation a lot of times. Is, okay, so we allow modular, a common box to be put in, to use simplistic, and all these different things that makes them communicate. They're still going to be relying on their own AI, on their own systems, and how good that is. And then they have to be able to communicate. So it's one of the, it's definitely a challenge of, if we want to get to the full networked autonomous level 5, that's I called it the pie in the sky, I think, in the brief. There's a long way to go. And Alex is exactly right. We hit on this too. Human and machine teaming is the foreseeable future. At what point on that quotes automation scale, the human has to come in when the AI throws a flag up and say, I need a human intervene? There's a lot of efficiencies to potentially get to a target in the warfare sense, but we still need the human at some point to say, yes, this is good, or no, you can disregard that. Take it as a data point. We got to make this better, and go from there. But yeah, fully networked machines is we're ways out from that, and being able to trust that in itself. And that's on top of just, hey, one drone going to strike a target with full AI. That's a big enough problem right now. I think that once we solve that, I think it'll create a exponential increase once somebody cracks the code on that and does it. They either may have a monopoly on AI in that sense, but it'll definitely increase the competitive nature and make us better but we're just not. I don't see anybody there. I may not know everything, but I don't see anybody that's there yet that can do that with such a high level of confidence that we're going level 5 autonomy. So wholeheartedly agree with what Alex just said.
Yeah, and so you lead into, I guess, one of my last questions, which is what are your top 3 recommendations for improving the autonomous systems and robotics industry within the defense industrial base?
Yeah, I'll go ahead and start and then pass it back to Shannon. So I talked about it earlier. I think the first thing is securing some of the vulnerabilities in the supply chain. And so a lot of these recommendations actually are from the class in general. And what we found is it's not just the direct supplier, but looking beyond the second tier and the third tier supplier to make sure that uh, we're either able to secure those supplies in the US or through friends, allies, and partners, and not rely on other countries that may have the capability to shut off those supply chains or put those supply chains at risk, and to a point where we need to produce something at the thousands and hundreds of thousands if we're unable to because of certain supplies or certain components, right? That's a significant risk. So I think one of those recommendations is figuring out how we secure that supply chain, whether that's onshoring, friendshoring, or just creating systems that don't have supplies reliant on other countries. And then, another one of those recommendations is just streamlining DoD acquisitions, the classification requirements. Shannon got to that a little bit. Really to strengthen industry participation. So we have great innovative firms, and you brought up a great point and talked about kind of that bottom up innovation that maybe South Korea might not have because of that government kind of centralized push down. This private partner mix allows us to have great innovation, firms that are able to come up with just amazing ideas, but we have to incentivize them to want to be in the DoD space. We've got to be a better customer, whether we're changing how we do acquisitions, where we're streamlining it, whether it's, a profit policy that we're changing, something so that we are an attractive partner for these small and large, very innovative firms to see the defense space as something that is not only great for our nation, but also great for their company.
Yeah, and I think that the incentive part is key there. Alex talked about and that's the difference in, say, like Republic of Korea. That's up front. The government says we're going to go in this. I think because our defense industry, regardless of the primes, but there's so many new venture capital startups and so many people saying they want this and want to get in the space. I think we have to have that incentive aspect of it, but I think we do a fairly good job now with DIU to say, here's our requirement. This is what we're looking for. Bring your product and make sure it's mature. And then they screen those and we start filtering out. And then we say what we're going to incentivize against that. So I think that's a different model, but a similar idea way to use government incentives to try to accelerate and foster some of these smaller firms to improve our acquisitions process. I mean, some people would argue that it's not really that, it's some funding. And the bottom line is the defense industrial base is not where it needs to be for strategic competition right now. So it's one of those things that incentivizing these smaller startups, to bring their products forth, validate them, and then scale them. That's the regular. Then we have to, hey, you got to come at scale, especially if you're using AI, edge compute type stuff. You got to be able to show us over multiple prototypes, not just singular, and then shows how you can improve it and where you can expand it. And do you have the supply chain, going back to that, it's all interconnected, the supply chain to support being able for the US DoD to say, yes, this makes sense for a long-term investment and developing iterations of that. So that's one of the I think the last thing, and going back to the modular open systems architecture, is that's going to be key. You got to bring your thing to bear, but you got to make sure it works with the network, because the command and control aspect of any military operation is the key. If you can take out someone's eyes and sever the communications link, then you can drastically impact their way to compete on the battlefield. And you can't bring a product that can't prove that it can't plug into everything else. And that's a real challenge for us with so many vendors, so many things. And we're going through this process right now through the replicators, et cetera, of new firms, new products, new this. Yeah, great. As long as we can adapt them into our overall hierarchy of communications, command and control, I think we can work with them. And I'd say the last thing is the same thing that goes with the Koreans, right? So, and maybe not the same, but once we allow all these companies in, and it goes to the classifications topic kind of Alex touched on, and we say, we'll buy your stuff, we have to make it easier for them to make money too. Like, and I don't mean easier in a haphazard way, but we have to be able to let them market their products overseas, like the Koreans do in the Middle East or wherever. They have to be able to make money. So yeah, we're going to help them on the front side. But if you're not talking about dual use technologies where they can have a commercial side of what they're making for us, when we have that monopoly, we can control what we're buying. We have to allow them some other revenue stream. They're just not going to survive. And then, they're very vulnerable to, disruptors coming in and say, hey, we like your product. We've made it a little bit better. And now what happens when you lose your product and you've leveraged your whole business trying to support the DoD? So letting them make that money to continue for themselves to innovate and survive is one of those, I think, key facets to that as well. So that's a lot, but it's a pretty complex, when you talk about recommendations, they're all connected and there's really nothing very simple about it all.
Yeah, those are great points. So do either of you have any final thoughts? Maybe something we haven't covered yet?
I think final thoughts, I think we come at attack it from a defense aspect. And I think there are a lot of ways that commercially we can use this. So I know that the academic government kind of defense iron triangle, if you will, is kind of weakened since World War II. And I think there's a lot of good ideas coming out of academia. It's just a matter of fostering those. So I think those grants and things for our universities are very important to keep going, because we visited with some MIT folks, some other folks that have some absolutely mind-blowing ideas, not just for autonomous systems, but in general. And they're at the point in their lives where they're really wanting to make a difference, and they're using a lot of brain power, some stuff that was just, for me, awe-inspiring, like that they're putting their effort into this stuff in graduate school. And you're like, wow, this is, how in the world would you ever come up with this? And so I think continue to make sure that we don't lose those incentives and those grants funding for our universities, because that was a key back in the, with the 50s, with the atomic bomb, if you will, and a lot of other things came out of non-military wearing, civilian clothes wearing folks. And if we lose that and we allow just the industry and the greater DC area here with the defense contractors to, I think we're cutting off a lot of the innovation, and we're getting them to do it at relatively inexpensive costs at that level. If you wait 10 years until they put on a suit and are working for the company, you're going to pay exponentially more for it. So I think I don't know if that makes sense, but that to me is a key aspect of what we've done in the past that we can go back to and go, oh yeah, that worked for us. Let's make sure we're doing that.
Yeah, I would say, just to further elaborate on that, just, create better relationships and sharing agreements, both internally, as Shannon said, with these think tanks and universities, and so that they're working for the DoD in a partnership type of relationship, but also with our allies and our partners. Resources from now on are always going to be limited. We are just not going to be able to produce everything that we need or want to. So by combining assets and sharing this intelligence, the advancements in ASNR, which is just rapidly accelerating in that specific space, I think that will ultimately increase our capacity here needed to face these future defense challenges.
Well, that's great. It's been a really great conversation. And thank you both so much for coming on the show.
Thank you, Dr. Kellogg. Appreciate being here.
Thank you.